Today, we're going to pull back the curtain on a hidden art form. I'm talking about the literal glue that holds our modern world together. It's a powerful science, and you see the results of it every single day, probably without even realizing what you're looking at. I mean, really think about it for a second. What is it that keeps those massive skyscrapers from toppling over? Or allows those giant ships to sail the oceans without breaking apart? Or even just holds your car in one piece? It's definitely more than just a few nuts and bolts. Well, the answer is a craft that literally fuses metal together using incredible heat and amazing precision. It's a process that has to combine the brute force needed to melt solid steel with the delicate, steady hand of a surgeon. And that art, of course, is welding. At its absolute core, it's a pretty simple idea. You melt separate pieces of metal until they actually flow together, becoming one single solid piece once they cool down. It is literally how we build our world, one powerful piece at a time. So how is it actually done? Well, it turns out there are 4 really common methods, and each one has its own special purpose. Let's break them down. Okay, so here's the quick overview. You've got MIG, TIG, stick, and flux-cored welding. Now, they mostly differ in what's called their electrode, that's the material that conducts the electricity, and how they protect that molten metal from the air around it. Think of this as our map for the next few minutes. First up, we have MIG welding. You know, the best way to think about this one is like a super high-tech, crazy powerful hot glue gun. But instead of those little plastic glue sticks, it's feeding out a continuous spool of metal wire. So the reason MIG is so popular is because of how it works. It uses what's called a consumable wire electrode, meaning the wire itself melts and actually becomes part of the final bond. This makes it really fast and super versatile, which is exactly why you see it everywhere from car factories to construction sites. All right, next up is TIG welding. Now, if MIG is the versatile workhorse, then TIG is the precision surgeon. This method is all about control, cleanliness, and creating absolutely flawless, high-quality welds. The big difference here is the electrode. It's non-consumable. It's made of tungsten because tungsten has an incredibly high melting point. So the electrode creates the electric arc, but it doesn't melt into the weld. The welder has to add the filler metal by hand. Yeah, it takes a lot more skill, but the precision you get is just unmatched. That's why it's so essential for industries like aerospace, where failure is simply not an option. Now for what is maybe the most iconic form of welding, stick welding. You've probably seen this in movies or at construction sites, right? It's that classic, all-purpose method for heavy-duty repair and construction work. Okay, the secret here is the flux coating on the electrode, on that stick. As it burns, it vaporizes and creates this protective cloud of gas. Now here's the really clever part. That gas shield physically pushes away all the oxygen and nitrogen in the atmosphere, which would otherwise mess up and weaken the weld. Because it shields itself, you don't need a heavy gas tank, which makes it incredibly portable and absolutely perfect for outdoor jobs. Our final method, Flux-Cored Arc Welding, is kind of a hybrid. You can think of it as taking some of the best features from MIG and stick welding and mashing them together for really heavy-duty work. So just like MIG, it uses a continuously fed wire. But like stick welding, the protection comes from flux. See, the wire is actually a hollow tube that's filled with that flux material. This creates a really strong, deep weld, which makes it perfect for massive projects like building ships or repairing huge pieces of machinery. So we've seen the methods, but what's actually creating that intense metal melting heat? Let's take a look at the different energy sources that power the spark. While electricity is definitely the most common, there's a whole menu of energy sources out there. Welders can harness everything from gas flames and lasers to even more exotic methods like ultrasonic vibrations and straight-up friction. We're going to focus on the most common ones. Electrical energy is pretty much the king. It's what creates that iconic electric arc we see in methods like MIG and stick. But then you also have gas energy, which uses a controlled flame from burning gases like acetylene to melt the metal. So you have 2 totally different approaches to get to the same goal: intense, focused heat. And this really shows you the high-tech end of the spectrum. The source material points out that laser welding uses a focused beam of light to melt metal. It's that incredible precision that makes it perfect for super delicate work in industries like electronics and, you guessed it, aerospace. Okay, we've covered the methods, we've covered the power sources, so now let's connect it all back to the big picture. Why does this hidden art matter so much? Here's the most crucial point. Without welding,
the world as we know it simply wouldn't exist. It is the foundational skill that allows us to build the massive, durable structures that define modern life.
So what this all comes down to is making the right choice for the right job. There is no single best way to weld. The right method always depends on the task at hand. You have to consider the material you're joining, how strong that bond needs to be, and what the finished product will actually be used for. So here's a little challenge for you. The next time you're out and about, look closer. Look for the seams on a steel beam, or the joints on a bridge, or even the panels on your car. You're not just looking at pieces of metal anymore. You're seeing the signature of a welder. Every single one of those seams tells a story of incredible heat, intense pressure, and human skill. So now that you know a little bit about the art behind the bond, what hidden structures and connections are you going to start seeing in the world all around you?